Hello everyone. In this one I'm going to be talking about something called accommodation. Now, accommodation in the biological sense refers to the ability of the lens to be able to change shape to focus the light. So let's write down exactly what this word accommodation means. So we said it is the ability of the lens to change shape to focus the light. And that's what accommodation means. And we look specifically at three particular parts of the eye. We're going to look at this part here, which is the lens. We'll look at the part in red here, which is the ciliary muscle. But we'll also look at these white sort of strands between the lens and the muscle, called the suspensory ligaments, and see how those three interact to bring about accommodation. So, we've got the diagram of the eye at the top left corner here. We're going to imagine we're looking at a close and an object close up and an object far away, and talk about how the lens changes. Now, in blue at the bottom, so I'll just draw a little black asterisk here. In blue, this is the shape of the lens. If we imagine just in a normal position. And let's say we're looking at something far away. So we're looking at a distant object. So we're going to do that one first. When you look at something far away, the ciliary muscles relax. So we'll just write that in here. So the ciliary muscles relax. Now when they relax, the suspensory ligaments tighten. So these suspensory ligaments, they're not muscles, they don't contract or relax, they'll either tighten or go loose. So when you look at a far object, they end up tightening. Now this is quite hard to visualise on maybe the diagram of the eye, so I want you to try and imagine, and we'll just shrink the screen for this, I want you to try and imagine this scenario. So imagine you are someone just sitting down flat here, feet outstretched, put your hand outstretched, and let's imagine tied to your feet and hands are a spring like this. It's a very quick sketch. Your arm and your leg would be the muscles, and the red part, the spring, let's imagine would be the ligament. So when the muscles relax, imagine if this man in this picture were to sit back, his arms would pull backwards. So when the muscles relaxes, it was as if his arms would pull backwards, but he would pull on the red spring between the feet and his hand. And that's kind of what the ligaments do. When the muscles relax, they end up tightening those ligaments. And when the ligaments tighten, they pull on the lens. So in this bottom picture, if we take the blue circle, I'm just going to draw in the ligaments at the top and the bottom. If we imagine pulling the one at the top up and the one at the bottom down, we'll pull on that lens and make it much thinner. So in fact, we'll reduce the curvature of the lens, and you end up with this green sort of circle on the left. The lens goes much thinner. In fact, it becomes much less convex. The lens becomes much thinner. We're able to focus the light rays on the retina. Now the complete opposite happens when we look at something close. When we look at an object nearby, the ciliary muscles actually contract. Now an easy way to remember that is close, contract, the two C's together. Now this time when the muscles contract, the ligaments loosen. Or another word for loosen is go slack. So let's just go back to our picture at the top. If we imagine the muscles contracting, it would be like in this picture if the guy were to lean forward and really stretch, try and bring his hand closer to his foot. And you can see by doing that, he'd loosen that kind of spring tying his hand to his foot. So the red part would kind of loosen or go slack, even whilst the muscles are pulling. And that's what happens in the eye. The ciliary muscles will contract when you look at something close up, and they'll loosen or slacken those suspensory ligaments. Now, when that happens, you'll get something like this red circle at the bottom. The lens will become a bit fatter. It won't be pulled so tightly. So actually, in terms of lens curvature, the lens will become much more convex. It becomes a lot rounder. And that's how the lens will accommodate for an object close up. Now I realise the picture in the corner of the guy is a very unusual way of looking at this. And in an exam question, typically, these tend to be 3 marks, and you often get 1 mark for referring to ciliary muscle, 1 mark for referring to suspensory ligaments, and 1 mark for saying how the lens is affected. But this is a little bit about accommodation and what the eye does to be able to focus properly. So what we're just going to talk very quickly about next is what happens when you have a certain condition. For example, when someone is short-sighted and long-sighted. What does the eye do in those instances, and how can we correct them? So let's these 2 diagrams here. Now what we have at the top is meant to represent short-sightedness. So we'll just write that in. This is meant to represent someone who is short-sighted. Now the proper word for short-sightedness is myopia. Now, in the case of someone who is short-sighted, they are able to see things very close up, but something very, very far away would look very blurred. And it's essentially because those light rays, if we see from the left, they're coming in, so it says light from the object, they're coming in. The lens here, so just where I'm drawing the black line, the lens here is refracting or bending the light towards the retina, but because it's so far away, the focal point is before they hit the back of the eye. So those lenses are focusing in, but they're meeting before they hit the back. Now, what we've done in this diagram is extrapolate those lines a bit further back. So we've continued them on, and you can see where they hit the back of the eye. What we'd get because of this is a blurred image. In the case of someone who is long-sighted, so we'll just put this in here, long-sighted, because that's what the diagram at the bottom is. Now, long-sightedness is called hypermetropia. So we'll just put that in. So in someone who is long-sighted, what we have here essentially is someone who can see distance very well. So they're long-sighted, far-sighted. They can see long distances easy, but when objects are very close up, they appear much more blurred than usual. And that's because the light rays once again come in and they're refracted onto the lens. But because the object is so close up, those light rays aren't able to be bent or refracted quick enough in time to focus on the retina. So again, we get a blurred image. And if we follow those light rays back, as we see here, the focal, it should say point there. The focal point, almost if we imagine, would be actually beyond the retina. So what we have to do is try and correct both of these. So we've got short-sighted at the top, myopia, long-sighted at the bottom, hypermetropia. Now in both instances there's a problem with the lens. The lens isn't able to accommodate, it's not able to change shape properly to focus that light. So there are 2 things we can do. There are one for each of these conditions. People can be fitted with, let's say, glasses or contact lenses with 2 particular shapes. If we gave someone a lens of this kind of shape, something we call concave, then what that actually does is help refract the light out a little bit more. So it almost like buys us a bit of time. So light rays would, if we draw 2 light rays in, they would hit the lens and they're refracted outwards. Now you can see a lens like this would be ideal for a condition like short-sightedness, because it would buy us a bit more time to be able to refract that light properly to hit the back of the retina. So, a very, very quick sketch. If we shrink, or rather than shrink the screen, just draw a bit smaller. If we imagine, here's the eye here. Again, very quick sketch. And we were to fit somebody with this concave lens, then what we'd have is the light rays coming in. Then that light would be pushed out a little bit more, which would give us a bit more time to then focus that light directly to the back of the eye. And that's how we treat short-sightedness. Now there is another lens, and we'll put this up at the top. And this lens here, you can see it's a bit more rounded. This lens is convex. And in this case, the light rays enter, but then they're refracted a little bit more. So a convex lens would actually be the ideal thing to use in someone who is long-sighted, and we'll draw a diagram just to explain why. So if we draw again the eye here, put a lens in place, and we imagine putting a convex lens in place just here. Then what we can have are the light rays coming in and brought in a bit sooner, because the problem with someone who is long-sighted is that the light rays aren't focused in time. So we could bring those light rays in sooner, which would help to focus them easier onto the back of the eye. So we could use a concave lens to treat myopia and a convex lens to treat hypermetropia. For the short-sighted person, by using a concave lens, we're able to push the light rays out a little bit more for the lens to refract them properly onto the retina. And in someone with long-sightedness, using a convex lens allows us to bring those light rays in a bit sooner, so that the actual lens of the eye can refract the light properly onto the retina. So, I hope that helps.